Hello students, this is lesson U2A01c. In this video I am going to go over assignment U2A01c where we are going to be solving quadratic equations. So let's take a look at this. I have this equation here which is 3x squared is equal to negative 6x minus 6. So just like before in past videos, okay, the technique was to bring everything over to one side, and we want to be able to identify well, we want to see whether or not this thing is factorable first. So let's do that. So if I bring everything over, I have 3x squared plus 6x plus 6 is equal to 0. I immediately see that we do indeed have a common factor of 3. So I want to factor that out. So if I factor that out, I'll end up with 3 times x squared plus 2x plus 2 is equal to 0. And then upon closer inspection, okay, I look at this number over here, okay, the possible factors that multiply out to 2 is 1 and 2. So no matter what combination of arrangement that I do, okay, I am not going to end up with a sum where it's going to be 2 there. So this thing is not factorable. Because it's not factorable, we're going to go ahead and use the quadratic formula. So let's take a look. The quadratic formula, if you recall, follow this format here. It's negative b plus or minus square root of b squared minus 4ac all over 2a. Now we're going to ask ourselves, like, what are the coefficients, what are the numbers for a, b, and c? So is a, b, and c supposed to be 3, 6, and 6, or is it 1, 2, and 2? Actually, at the end of the day, it really doesn't matter. However, because we want to simplify things for ourselves, it would be more advantageous for us to choose smaller numbers. So I'm going to choose 1, 2, and 2 instead. But if you decide that you really do want to use the original numbers in the problem, like 3, 6, and 6, you can certainly do that. At the end, everything's just going to reduce down, and we're going to achieve the same solution regardless, okay? But this just makes things a little easier. So I want to substitute that in, okay? And if I do that, I'll end up with x is equal to negative 2 plus or minus square root of 2 squared minus 4 times 1 times 2. All divided by 2 times 1. And upon further simplification, I can then see that I have negative 2 plus or minus square root of 2 squared is 4. 4 minus 4 times 2, so that's 4 minus 8. So that's negative 4 all over 2. And if you look at this right now, okay, we have a situation there where we have not encountered this year, and that is we have a square root of a negative number. If you recall, okay, or if you understand what this is saying is, okay, there's no such thing as a number when you square it, okay, where we are going to end up with negative 4. Try that, right? So this is like saying, actually I'm not going to use x, I want to say use n. So let's say if I have n is equal to 2, right? So if I take 2 and I square it, I am not going to end up with negative 4. Similarly, if I make n is equal to negative 2, I am not going to end up with negative 4 as a result, right? So what does this mean? Well, there is a solution here, okay? And the solution is, like what all mathematicians like to do whenever they encounter something that they don't know, or that they don't know how to manipulate or handle, okay, what they do is they actually separate things out. So really, we're going to separate out the square root of 4 and the part that confuses us, which is negative 1 there, okay? And what we do then with this is, this becomes negative 2 plus or minus 2 square root of negative 1 over 2. And what will that reduce to? Well, the 2's, okay, will divide evenly into both parts of the numerator there. I'm left with negative 1 plus or minus square root of negative 1. So to make things even more simpler, okay, even simpler for everyone, right, this is the widely accepted value for square root of negative 1. We call that I. I is an imaginary number, okay? So this I represents square root of negative 1. So my final answer at the end is negative 1 plus or minus I. This is my final answer here. So this solution that I have, okay, right now, this is an imaginary solution. An imaginary solution, if you recall, from back in Algebra 1, okay, a quadratic equation, okay, can have two solutions, one solution, or no solutions, right? So when we have no solutions, okay, we actually have imaginary solutions. This is where the parabola does not hit the x-axis, okay, but instead we have these imaginary roots, okay. So let's take a look at another example. So I have 9x squared plus 7 is equal to 12x. And what we want to do, okay, is again bring everything over to one side. And I arrange it in standard form. I'm going to continue and I'm going to check this out. There's again, this is something that's not factorable. And how we know that is because if you try out the different combinations, right? We have, let's say, 3x and 3x. If I place 7 and 1, right, we are not going to end up with 12 in the middle there. Similarly, if I make this a 9 and the other a 1, okay, there's no way that we're going to end up with 12, no matter where we place the 7 and 1. Okay, so this thing is not factorable. Because it's not factorable, again, we are going to use the quadratic formula. And right now there's no common factor, so we're just going to directly substitute in. If we do that, we'll end up with negative b, which is positive 12. I'm sorry, it's positive 12. And then plus or minus square root of b squared, so it's 12 squared, minus 4 times 9 times 7, all divided by 2 times 9. We're going to continue with the simplification here. We have 12 plus or minus square root of 144 minus 4 times 9, that's 36. 36 times 7. Again, that's my Achilles heel. I don't know how to do, let's see here. 36 times 7, so that's 221, so that's 252. Okay, so I have minus 252 all over 18. And we're going to continue simplifying. This is 12 plus or minus square root of, so now I have 144 minus 252. You know what, I'm just going to get a calculator. So I have 252, so I have 144 minus 252. That's going to be negative 108. So that's square root of negative 108. And all over 18. And if you look at this right now, again, we have that same scenario as before. And like I said before, the approach that we're going to do is we're going to separate out the square root of negative 1, the part that's imaginary, okay, from the part that is real, okay. So this square root of negative 108 becomes square root of 108 times square root of negative 1. But like I said before, square root of negative 1, there's a simpler notation. That's just I. Okay? And this is over 18. Now the operation in between here is still, there's still an operation. It's multiplication. So therefore, okay, I need to simplify the 108. And I know that 36 divides evenly into 108. It divides evenly into it 3 times. So I have 12 plus or minus, so square root of 36, that's just 6. And then times square root of 3i, all over 18. And is there a common factor between the numerator and denominator? You look at 12, 6, and 18, the common factor is 6. So therefore I want to divide every term by 6. 6 goes into 12 twice. 6 goes into 6 once, so I'm left with just 1 radical 3i, and the denominator becomes 3. So my x, I'm going to end up with 2/3 plus or minus radical 3 over 3i. This is my answer here. So these are the imaginary roots. So I was watching YouTube the other day, and I stumbled upon a really cool video just to talk about this concept of what exactly is an imaginary number and why we're studying it. So if you feel like enriching yourself with like the why and how of why is this topic even introduced, or why we go over it, okay, I highly encourage you to watch that video. The person that narrates and go over the video, I think she's great, she's excellent. So do definitely check that out. Let's go over another example. Let's go over this guy. So again, same approach, okay? What we're going to do is we're going to bring everything over to one side. I have 12x squared minus 9x plus 11 is equal to 0. And what I'm going to do is, again, this thing is not factorable. So we're just going to jump right in and apply the quadratic formula. So negative b, so that's positive 9, plus or minus square root of b squared. So that's 9 squared. Minus 4 times 12 times 11. That is going to be a big number. I'll definitely need a calculator in a moment. And then 2 times 12. So what I end up with is 9 plus or minus square root 81 minus 4 times 12 times 11. Oh boy. So let's do that. 4 times 12 times 11. That's 528. So minus 528 over 24. And we're going to do 81 minus 528. That's negative 447. So that's negative, so square root of negative 447. 9 plus or minus that all over 24. And is there any number that's going to be divisible by and divide evenly into 447? I'm gonna say maybe 3. So let's test that out. Why I say 3 is because the singlest digit is 7, right? And the only number that I can think of that that has a singlest digit is 3 times 9. So maybe possibly this thing is divisible by 3. Let me see here. And in fact it is. And then we have 149 there. Is this then divisible by any other things? 149, is it divisible by 7? No, it's not. So 149, I'm not sure, is it divisible by 3? It's not divisible by 3. 149, I don't think this thing is divisible by anything else, actually. Is it divisible by, let me see here, a number with the single digit, that's 9. Nothing else comes to mind, because anything multiplied by, let's say 6, 5, 3, no, it's not divisible by 3. So actually, 447, okay, is where we're going to leave it, because there's no perfect square that divides evenly into 447. So we have 9 plus or minus square root of 447i all over 24. Okay, and that's our x value there. I'm just going to actually double check that. Let me see here. Question number 3. It is. So we got it right. Okay. All right. So let's maybe do one more, and then we'll close the video, because all the other ones actually, yeah. So I have this. 5b squared minus 10b is equal to negative 9. So again, 5b squared minus 10b plus 9 is equal to 0. And so what will b equal to? B is equal to positive 10 plus or minus square root of 10 squared minus 4 times 5 times 9 all over 2 times 5. So what will I end up with then? I end up with 10 plus or minus square root of 100 minus 4 times 5, that's 20. 20 times 9, that's 180. All over 10. I have 10 plus or minus square root of negative 80 all over 10. And is there a perfect square that divides evenly into 80? And that would be 16, right? So I have 10 plus or minus square root of 16, that's 4. square root of 5, right? I, all over 10. And this can be reduced even further. This is just 2 divides evenly into everything, so it's 5 plus or minus 2 square root of 5, I, all over 5.